Our world is 3D, and certain spatial questions can only be answered in 3D space. For example, did this aircraft, the red line shown here, enter airspace? Or which areas are not visible from the road, and what is the depth of invisibility in those particular areas? What's the risk of flying along a planned route, taking into account the range domes of anti-aircraft guns? In 3D, you can find out what the maximum building height is before buildings become visible from public places such as roads and parks. And determine where and how high development can be allowed without changing the skyline from important locations. We can analyze how visible will a new proposed building be from surrounding buildings, and get an indication of solar exposure of the new building design for any day in the year. We can calculate percentage of sky that can be seen from the streets in urban areas, and analyze the shadow impact at ground level for any given day in the year. Not only at ground level, but we can also find out how the shadow of a new building will affect surrounding buildings. And determine if a new proposed building will cause potential glare effects. We can find out the line of sight coverage along a proposed parade route, and also go inside buildings where we can answer 3D questions such as how much sun will be inside my apartment. Or find the areas inside the apartment that can be seen when looking in from outside locations. We can analyze interior 3D networks to improve evacuation times. And also go underground and estimate soil volumes that need to be removed for a new tunnel design. Or, for example, find the distances at which wells intersect with underground deposits. And generate fence diagrams to better understand subsurface layers. The point is that working in 3D space is essential to solve such problems.